This video will be on factoring polynomials, and we're going to look at some special cases. So the first special case that we're going to look at is sum and difference of cubes. Before we start, let's just remind ourselves what a perfect cube is. So if you cube 1, you would get 1. So 1's a perfect cube. If you cube 2, you would get 8, and so 8 is a perfect cube. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125, and so forth. So if you cube a number, it will get you a perfect cube. And so what we're going to have is in a problem, and say in this example, we'll take 8x cubed minus 27, and we will factor that. And so it is a difference of cubes situation because you have a perfect cube right here minus a perfect cube. So we call that a difference of cubes. And it can be factored by using this formula. A minus b times a squared plus ab plus b squared. To figure out what a and b are, so you can use the formula, you're going to ask yourself this question. What got cubed in order to get 8x cubed? You can't say 8x cubed is a. You have to say what got cubed. So 8 comes from 2 being cubed, and x cubed comes from x being cubed. So a is 2x. And then 27 comes from 3 being cubed, and so b is 3. So your a is 2x and your b is 3. And now you just substitute into the formula. So 2x minus 3, parentheses, 2x squared plus 2x times 3 plus 3 squared. And then simplify. So the first parentheses will stay the same, 2x minus 3. And then the next parentheses will have in it 2x squared, which is 2x times 2x. And so that's 4x squared plus 2x times 3, which is 6x plus 9. And the wonderful thing about this is that you actually do not have to go any further. That cannot factor anymore. And so that is your answer. Let's try another one. So let's go with 125 x to the fourth minus, and let's go with 27x. Remember, the first step always when you're trying to factor is you want to take out the greatest common factor. And so you take out the GCF, and in this problem it's going to be x, and then it leaves you with 125x to the third minus 27. Actually, let's make this problem a plus, because on the last one we did a minus, so let's make it a plus. And so then it is a perfect cube, 125, and 27 is also a perfect cube, and so we can factor by doing a sum of cubes if you're looking inside the parentheses. And the formula for that is a plus b, and it looks very similar, a plus b, and then it's a squared minus ab plus b squared. And that is the formula that we're going to use inside the parentheses. So what number got cubed in order to get 125? 5. And what got cubed in order to get x cubed? X. So 5x is a. And then b, what got cubed in order to get 27? 3. And so now we substitute in the formula. So it would be 5x plus 3. And then a squared would be 25x squared, because 5x times 5x. And then a times b would be 15x, so minus 15x, plus b squared, which is 9. And remember, that is your answer. Oh, got to put that x in front. Almost forgot that. If you take out a GCF, all you've got to do is put it in front after. And so that is how you factor using sum and difference of cubes. Okay. The last one would be a problem where you may have to factor more than you realize. So if you have something like x to the fourth minus 81, this is not a perfect cube problem. It's not a perfect cubes or sum of cubes or difference of cubes, because 81 is not a perfect cube and neither is x to the fourth. It's actually difference of squares because they're perfect squares. And we said the formula is a plus b times a minus b. And so you say square root of x to the fourth is x squared, and the square root of 81 is 9. So we go x squared minus 9, x squared plus 9. But the one thing that you're going to have to ask is, can I keep factoring? And sometimes when you have these higher exponents, the answer to that question after you factor initially is that you have to actually keep going. The answer is yes, I can keep factoring, and it's right here with x squared minus 9. It's another difference of squares problem. So the final answer would be x plus 3 and x minus 3. That's coming from x squared minus 9, and then the x squared plus 9 will stay the same. And that would be fully factored. All right, have a great day.